Reference angles. We will often evaluate trigonometric functions of positive angles greater than 90 degrees and all negative angles by making use of a positive acute angle. This positive acute angle is called a reference angle. Right, so let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle, theta prime, formed by the terminal side of theta and the x-axis. So here below I have three diagrams showing you how to find the reference angle for theta lying in quadrants 2, 3, and 4. Notice that the formula used to find the reference angle varies according to the quadrant in which theta lies. All right, so let's take a look here. So we don't have one for the first quadrant because the first quadrant is its own reference angle because it's less than 90 degrees. All right, but in the second, third, and fourth quadrants, the angles are greater than 90 degrees. So we need to find a reference angle, a positive angle that's less than 90 degrees, for that angle that's more than 90 degrees. So in the second quadrant, right, so I'm going to use this little arrow to point here. In the second quadrant, right, so if we take the principal angle and the reference angle together, they equal 180 degrees or pi radians. All right, so together, principal plus reference equals 180 or pi. So if I want to find the reference angle, we're just going to subtract our principal angle from 180 degrees or from pi, depending on whether we're working with radians or degrees. All right? So principal angle is just 180 degrees minus the principal angle. All right, now if we're in the third quadrant, now we've gone past pi. All right, so together 180 or pi plus the reference angle equals the principal angle, because the principal angle goes all the way over here. Right? And so this is our reference angle. So notice the reference angle is always the distance to the x-axis. Right? So we always go to the x-axis. So there's going down to the negative x-axis, going up to the negative x-axis. And so the reference angle, since 180 plus the reference angle, or pi plus the reference angle equals the principal angle, we'll simply subtract pi, or 180 degrees, from our principal angle to find our reference angle. And then in the fourth quadrant, notice that together the principal angle and the reference angle equal the whole circle, equal 360 degrees or 2 pi. So since principal plus reference equals 360 or 2 pi, if we want to find the reference angle, we'll simply subtract the principal angle from 2 pi or 360 degrees, depending on whether we're working in radians or degrees. Oops, didn't mean to do that. There we go. All right, so let's take a look at a few problems. All right, so we're going to find the reference angle, theta prime, for each of the following angles. All right, now I will draw a picture as well. Helps to see what quadrant you're in. All right, so 345 degrees. I'm going to label this with degrees since we're in degrees. So 0, 90 degrees, 270, and 180 and 270. Got ahead of myself. There we go. All right, so, and then this course would be 360 all the way back again. All right, so 345 degrees is going to be in the fourth quadrant. All right, so here is our angle. Our reference angle, we go back to the x-axis. This time we go up to the positive x-axis. And here is our reference angle. Here is our principal angle. So to find our reference angle, we're simply going to take 360 degrees and subtract the principal angle. So that means that our, and this is our reference angle, just to remind you, our reference angle equals 360 minus 345, or 315, 15 degrees. All right, so that's all there is to find the reference angle in the fourth quadrant. And now we're going to work with, to write a little smaller, with radians. All right, so this would be 0, this would be pi halves, this would be pi, this would be 3 pi halves, and all the way around is 2 pi. All right, well, 5 pi 6 is more than a half. 5/6 is more than a half, but not as much as pi, as a whole pi. So it's going to be here in the second quadrant. Actually, I should have labeled the first one with the fourth quadrant. There we go. All right, so we're going to be in the second quadrant. So here is our, I'm going to switch colors here. Here is our principal angle. Actually, I already did switch colors. Our reference angle. And here is our principal angle. All right, so together, the principal angle plus the reference angle equals pi, because we're in radians. All right, so if we simply subtract pi from the, if we subtract our principal angle from pi, we'll get the reference angle. So the reference angle is pi minus the principal angle, which means pi minus 5 pi 6. And of course, pi is the same as 6 pi 6. So that means our reference angle is pi 6. I am going to make a duplicate of this page because I am running out of space. All right, and let's do the last. I can maybe fit the next one in, but the last one I'll do on the next page. All right, so I'm just going to erase this because he's going to be on the next page. All right, so negative 135 degrees. First of all, let's label this 0, 90, 180, and 270, and up to 360. All right, so first of all, we need a positive angle because our angle is negative. If I take negative 135 and add 360 degrees, we will have a coterminal angle. So a coterminal angle is an angle that has the same terminal starting and terminal ends, terminal arms, but goes a different direction or doesn't go around the circle as many times. So negative 135 is over here. Our coterminal angle, therefore, negative 135 plus 360 would give us 225. All right, so the angle that we're interested in, therefore, is this one. All right, notice, see, they start and stop at the same place. They both start at the positive x-axis, as all angles do, and they both end in the third quadrant, but one goes clockwise and one goes counterclockwise. So the clockwise one is the negative 135, the counterclockwise is the positive 225, and that's what we'll use to calculate out our reference angle. So the reference angle, and I shall just put reference angle, is going to be, so our reference angle plus 180 degrees equals our principal angle. Because here's where our reference angle is located. And let me squeeze that in. There we go. Our reference angle is right there. So our triangle goes to the x-axis, and our reference angle is from where the principal angle ends back to the x-axis. So together, 180 degrees plus our reference angle equals the principal angle. So to find our reference angle, we're just going to subtract 180 from the principal angle, which means our reference angle is 225 minus 180, or 45 degrees. All right, and that's all there is to finding reference angles. Now, actually, we have one more. Can't forget the last one. This one here. Because this one looks a little different. So I'm going to just get rid of all of this. And now let's deal with the last one there. All right, so this number looks a little different. And we lost our decimal point. It didn't move along with us. All right, it's 2.5. If you don't see a degree symbol, right, then it is in radians. Right, so it just doesn't have. So even if it doesn't have pi with it, if there's no degree symbol, it is in radians. Right, so let's draw our coordinate plane. So 0, pi halves, pi, 3 pi halves, and 2 pi. And you might wonder, where do we put this one? All right, so if we take pi and divide it in half, okay, so we know what pi is, right? Pi is about 3.14. So it's not past that amount, right? And so if we take half of that, that's 1.57, I believe. So 1.57. So our angle is more than 1.57, which is the numerical value for pi divided by 2, but less than the numerical value for pi. So that means that our angle, our principal angle, is right in here. All right, and so again we go to the x-axis. So this is the principal angle, that one's 2.5. And then this is our reference angle that we're trying to find. All right, so it's just like, so we're in the second quadrant. So we had, I think, another one in the second quadrant already. So again, the principal angle plus the reference angle together adds up to pi. And since we're not dealing with a number multiplied by pi, we're dealing with just a constant there. Let's, instead of using pi, let's use 3.14. And so we'll just round to 2 decimal places. All right, so now to find, and so pi, let's replace our values here, and then we can find it. So now our principal angle was 2.5. We're looking for the reference angle. Actually, you know what? Let's just subtract first. So our principal angle is going to be 3.14 minus our principal angle. And the principal angle, remember, was 2.5. So I'm just going to put the 2.5 there because I'm afraid I'm running out of space here writing down. I think I made my coordinate plane too big. All right, so 3.14 minus 2.5. I wish I had a calculator handy. So let's see. That is... For some reason, decimals are hard for me to do in my head. All right, so if I add, I know I can do it. If I add 0.5, I'll be up to 3, and then I need another 0.5. So 0.64. There we go. So our reference angle right here is 0.64, a little unique one there. All right, so the rules are the same, even if your radians don't have a pi included. Just know that if you see a number, no degrees, it's radians, not degrees. Oh, whoops. Well, it looks like I made 2 of these. I guess I made 2 of those. That's okay. We'll get rid of this one later. And let's just keep on going. All right, so finding reference angles for angles greater than 360, 2 pi, or less than 360, negative 2 pi. And we already saw one like that. We had a negative one. So you need to find a positive angle less than 360 or 2 pi that's coterminal with the angle. You'll draw your angle in standard position and use the drawing to find the reference angle for the given angle. And those drawings are really helpful because it puts you in the right quadrant. The positive acute angle formed by the terminal side of A and the x-axis is the reference angle. So that positive acute angle that's formed by your angle that you're given, in this case it's going to be a coterminal angle, and the x-axis, either the positive side or the negative side, is going to be your reference angle. All right, so let's first find the coterminal angle before we do any graphing, because we'll get a little busy with these large angles. All right, so our coterminal angle, we're greater than 360, so we're going to take 580 and subtract 360, so that's going to give us 220 degrees. So now we can graph that one. We're in degrees, so 0, 90, 180, 270, 360, and then we'll graph it. 220 is going to be right here in the third quadrant. The angle goes to the x-axis, so this is our principal angle, our reference angle right there. So this was our principal angle at 220 degrees. We need to find our reference angle. So our reference angle is going to be equal to our principal angle minus 180 degrees, right? Because we've kind of gone through the formulas already, right? Because together, the reference angle and 180 degrees equals our principal angle. So our principal angle was 220. And so 220 minus 180 is going to give us 40 degrees. So our reference angle is 40 degrees. And just as a reminder that, can I squeeze it? This equals principal angle, so I don't have to keep writing it. And this equals reference angle. All right, let's try the next one. All right, so 8 pi thirds, that's more than 2. All right, so we need to find a coterminal angle. All right, so 6 pi thirds would be 2 pi. So we're going to subtract 2 pi, or 6 pi thirds, from our principal angle, and now we get our new principal angle at 2 pi thirds. All right, so we're in radians. So 0, pi halves, pi, 3 pi halves. We are in the, I keep forgetting to write in the quadrant we're in. There we go. We are in the second quadrant. We are right there, because 2/3 is less than a whole. All right, and so we are in quadrant 2. This is the new principal angle, 2 pi thirds. And now we need to find our reference angle, which, remember, we draw a line to the x-axis. So if we subtract the principal angle from pi, we will get what's left over, the reference angle. So our reference angle equals pi minus 2 pi thirds. Of course, pi is the same as 3 pi thirds. And 3 pi thirds minus 2 pi thirds means our principal angle is pi thirds. Our reference angle is pi thirds. My tongue is getting tied today. All right, now on to the last one. Right in this color. And my recording box, which tells me how long my recording is blocking what we're looking for. Negative 13 pi 6. Oh, let's find that angle first. All right. So we have, I guess I should write in the same color. 13 pi 6. We'll color code this. All right, so, negative 13 pi 6. So here we are negative. All right, so to find a coterminal angle, we need to add, if we want a positive coterminal angle, we need to add 2 pi. Now, if we add 2 pi, which is the same as 12 pi 6, you see that we are still negative. You can add 2 pi again, or you could have added 2 times 2 pi, or 24 pi 6. That's okay. We'll just add another 2 pi. And so our coterminal angle is 11 pi 6. So let's go ahead and draw our nice little coordinate plane. Let's label it 0, pi halves, pi, 3 pi halves. All right, and 11 pi 6, of course, is going to be here in the fourth quadrant. So here we go up to the x-axis to find our reference angle. So this amount here was 11 pi 6. And we are in the fourth quadrant. And so now to find the reference angle, we're simply going to subtract the principal angle from 2 pi. So, 2 pi. So we have 2 pi minus 11 pi 6. And of course, 2 pi is the same as 12 pi 6, which means that our reference angle is pi 6. And there we go. That's all there is to finding reference angles. All right, in the next section, we are going to be using those reference angles to evaluate. Thanks for watching. Bye for now.